Hi, good afternoon or good morning, depending on where you are in the world. I'm Bernardita Sallato, and I'm gonna talk about early defoliation that reduce yield, nutrient concentration, and improve hardiness in sweet cherry Selah variety on behalf of the co-author Matthew Whiting and Brent Arnold-Dusen from Washington State University. So sweet cherry in Washington is a very important crop. We have 17,000 hectares approximately, with 210,000 tons of production, which represents 63% of US total production. And the area here that you see with a blue dot is precisely where most of the cherry is grown, and also where the trial was located. This area is an arid region and requires irrigation for having any tree fruit type. And one of the challenges that we have in our region is that we do suffer occasionally from frost damage during the fall or during the spring. So given the extensive work that has been done in other species that have shown that early defoliation can reduce the cold damage and improve hardiness in different species, we wanted to evaluate how this practice can reduce frost damage in sweet cherry grown in our region. But also as a secondary goal, we wanted to evaluate this practice of leaf removal early in the season for several other benefit practices here in Washington, for example, reduce diseases and control excessive vigor. So what we did here is, this is a sweet cherry orchard with the cultivar Selah, grown in Washington State University Experimental Farm, located in Prosser, in that dot that I showed you before, in a UFO system 1 by 4.5 meters apart. And these trees were planted in 2006. So this is a mature orchard, and we have two main treatments. One is a chemical application of 2% urea and 2% zinc sulfate as a chemical defoliant. And we also have a hand defoliation that we did, of course, by hand. You can see Matthew Whiting there taking the leaf from each single leaf from the trees. Besides these two treatments, we have 3 different dates where we apply these two treatments, date at 70, 60, and 50 days before predicted natural fall. And so we will call this date 1, date 2, and day 3. The treatments were applied in 2017 and 18, and the evaluations were done in 2018 and 19, so the following spring. What we evaluated was, of course, the main goal for hardiness during spring, but we also evaluated nutrient in the buds and in the leaves, and we end up with the evaluation of yield and fruit quality, of course, of importance for growers. So let's go directly into the results here. What I'm showing is a chart where the line here, you have the temperature in Celsius, and in the y-axis, you have the mortality in percentage. So what you can see here is a curve of the mortality when you start reducing the temperature in the buds and in the flower buds. The first year, what we observed is that the control was significantly different from any of the other treatments in terms of the average mortality, temperature for mortality. In 2019, on the other hand, we only see difference with the hand defoliation at the second date of defoliation. So this was 60 days before natural leaf drop. And we did not see any difference between the rest of the treatments and the rest of the treatment with the control. So the only one that had a significant reduction in cold damage and improved hardiness was the hand defoliation in the second date. Although I have to point out here that we did not have samples for the hand defoliation on the third date. Once we obtained those results, we also wanted to evaluate what happened with the nutrition in the trees, because we know that there is evidence that if we remove the leaves earlier, we might affect the levels of nutrients for the following spring. So we wanted to evaluate those levels in the buds and in the leaves. For the leaves analysis, there were no difference between treatments for either of those years, and so there was no nutrition effect in terms of the overall tree. However, in the buds, we did observe that the two treatments, HD1 and HD2, hand defoliation at the first and second date, reduced significantly the amount of nitrogen concentration in the buds in the following year when compared with the rest of the treatments and the control. These results were similar also for nutrient levels in the buds in 2018. For nutrient levels related to zinc, we observed that the only two treatments that had an impact and a reduced level of zinc in the buds were those that were developed early in the season. The first spray application and the first hand defoliation both reduced the levels of zinc in the buds when compared to the control and the rest of the treatments. Now, when we evaluated fruit quality, we observed also and consistently that the hand defoliation done at the very first day, 70 days and 60 days before natural leaf drop, were the only ones that were significantly higher than the control and the spray at first and second date. So here you have the hand defoliation was the one that had higher impact in firmness, one of important characteristic for fruit quality. And in terms of fruit per tree, which represent the total yield, we observe that, again, the hand defoliation on date 1 and date 2 were the only two treatments that had a significantly different compared to the control and the spray application. Okay, so to summarize the results, there's more that you will see in the final, in the abstract. There's a lot to share in 15 minutes, so I'm gonna share the conclusions that we obtained in this trial. So for the hand defoliation, on date 1 and date 2, we observed that the following season, we had a reduction of nitrogen in the buds to up to 19%. We also obtained lower yields, which is consistent with the literature showing that if you remove the leaves early in the season, you are reducing that source of nitrogen that it's gonna be a resource for the following season growth. We also observed that with the defoliation, the hand defoliation, we improved firmness in the fruit for both dates for up to 20 points in firmness. And we also have the benefit of improving cold tolerance, tolerance to cold temperatures with the hand defoliation on date 1 and date 2. For the chemical defoliation, where the leaves were not dropping as aggressively, of course, as we do with the hand defoliation, but there was a clear yellowing, which you can see in the picture behind, we obtained also that in date 2 and date 3, with chemical application of zinc and nitrogen, we increased and 38% the zinc levels in the buds. We had the highest yields were on those two treatments on day 2 and day 3, and there were no difference in fruit quality. So with that, we are able, with this information, we are able to make decisions regarding the needs of your own orchards and the possibility to do this defoliation by chemical application for the benefits that we mentioned before. For example, in terms of the hand defoliation, we will not do it, but we know that there is technology that is now available to do a complete defoliation, which can replace that hand defoliation, and that will allow us to improve hardiness, improve firmness under our conditions. But we have to be careful because if we have a weaker orchard or an orchard with a reduced levels of nitrogen, we can affect the productivity, the yield of that orchard. On the other hand, the chemical defoliation can be used if we observe here that because we are applying urea and zinc, the levels of zinc in the buds were available the following season for the initial growth. And we did obtain higher yields with the application of that urea 2% and zinc sulfate at 2%. However, there were no difference again in fruit quality, and there were no difference regarding nutrient levels in the tree, in the leaves. So with that, we understand that if we do this practice, for example, for other reasons, like I mentioned initially, to remove the leaves that can lead to an inoculum for a disease for the following year, or in our case in Washington, we are dealing with the little cherry disease, which is transmitted by leaf hoppers that are feeding from the leaf, of course. So having the leaf hoppers, we know that we have them in the fall, late in the season. So this practice could help us reduce the leaves earlier, so we don't need to continue spraying or managing those leaf hoppers and reducing the possibility of transmission of the disease. So with that, I finished the presentation on behalf of my two co-authors, Matthew Whiting and Brent Arnold Dusen, and I hope we have some time for questions during the meeting.